How do you stop the Kaminsky attack? This was uncovered sometime in the 2000s, and it caused a big panic. People noticed that a very core part of the internet, namely DNS, that we thought to be secure against off-path attackers, is suddenly not secure at all. 65,000 weeks has become 65,000 seconds in terms of how long the attacker needs to succeed. So there was a big panic. People got together. They had to brainstorm how to fix this really quickly and deploy it across the internet because it was such a big security vulnerability. So there was a big panic. So you might think that the best possible solution would be to increase the number of bits in the ID number. This shouldn't be 16 bits. It should be 32 bits. That would be 4 billion tries before the attacker succeeds. Or make this 128 bits. Now the attacker is never going to succeed before the universe ends. So why couldn't they do that? Remember, the internet is already using this DNS packet structure. So if I wanted to change the ID number to be longer, I'd have to go to every single computer in the entire world and tell all of them that ID numbers are now 128 bits, and they all have to update their code. And if any one host doesn't update their code, either they stop getting DNS working or they're still vulnerable to this attack. So we could try and change how DNS works, but we don't have the ability or the energy to go to every single computer in the world and tell them to fix this problem. So this is yet again not designing in security from the start. Because this wasn't thought about from the beginning, we now have to come up with some ugly fix to solve it, because we can't go and do one of these cleaner fixes that involves redesigning DNS. So what's the ugly fix that we did without breaking DNS so that we could get this fix out as fast as possible? Well, the ugly fix is to use this source port value. Remember, we said that the source port can be any number the client wants. You pick any port that you want to send the packet, and the response comes back on the same port. It's your own computer. It's like the private rooms in your own apartment or your own home. They can be any number that you want. So by asking everyone to randomize this source port number, we create an extra thing that the off-path attacker has to guess. Now, they have to guess the ID number, and they also have to guess the exact source port number. So now there's 32 bits that they need to guess, and now instead of 65,000 tries before succeeding, they have to try 2 to the 32 times before success. That's roughly 4 billion tries. So that makes the attack hard again. The Kaminsky attack is still possible on the modern internet, but because it takes 4 billion tries with source port randomization, it becomes a lot harder to execute. So this was the somewhat hacky fix that they came up with, was randomizing the source port. If you think that 2 to the 32 is not good enough, you can try to increase the entropy even further by adding random capital letters in the domain. So it turns out that google.com is the same whether you leave the characters lowercase or capital or some mix. So you could maybe try and add some random capital letters like lowercase g, capital O, lowercase g, and so on, and see if the response has the same capitalization. Not everyone does this, but it's another possibility if 2 to the 32 is not enough for you. So that's our defense. It's kind of hacky, but it's what they do. So one other defense that people have come up with is to not cache those glue records. So remember that the additional section was what we were using to poison www.google.com. So one possible defense is to not cache those records in the additional section. They're not our final answer. They're just an intermediate thing that we might need that might be helpful. For example, it might tell us in normal operation where the name servers are located. That's a useful piece of information, but it's not our final answer. So we're not required to cache it. And one possible approach is to always throw away those glue records. That would also stop the attack that we showed. Or if you want to cache those glue records, you can just make a separate DNS lookup to double check that the record is correct. So if someone gives you something extra in the additional section that wasn't your original question, just make a separate request. It's a little bit more work, but it lets you double check that no one was messing with you from the Kaminsky attack. Some people do this, some people don't, but that's another possible defense.